In the previous lecture, I reviewed Noam Chomsky's critique of B.F. Skinner's theory of language as developed in Skinner's verbal behavior. And I think you might recall from that critique that Chomsky has linguistic functions not conditioned by operant conditioning or any such associative process, but rather arising from the internal organization of language systems within the brain. So in that very critique, we begin to see a movement away from what might be called a descriptive science of human behavior, based on the notion that all of the determinants of behavior are out in the environment, and toward a psychology based on internal processes of the sort we will come to regard as cognitive processes. So the movement here is away from a radically empiricistic psychology, a psychology based on the notion that all of the contents of mental life arise from direct experience, toward a psychology of a more nativistic variety, a more genetic variety, one that strikes one as quite similar to what Plato had in mind in ancient times and Descartes had in mind in the 17th century. Well, the question then arises, are there really innate ideas, and how should one understand the notion of the innate as it applies to psychological processes? Surely John Locke was right that a man born blind from birth on regaining sight or gaining sight for the first time would have no idea of scarlet or green. So obviously much of what we know depends on direct daily contact with the environment. Nonetheless, there do seem to be innate principles and processes absent which experience itself would be meaningless, indeed unintelligible and largely impossible. Now, in an earlier lecture, I referred to Immanuel Kant's extremely influential, highly rationalistic philosophy, and Kant's insistence that in order for the Humean program to work, in order for David Hume's associationistic psychology to work, in order for ideas to be formed as a result of frequent associations in time and space, there would have to be an innate or a priori framework of time and space, because time itself and space itself are not given in sensory experience. One doesn't see time or feel time. One doesn't smell space. So Kant argued, and argued quite effectively, that all experience must be grounded in, within the framework of space and time, and thus the pure intuitions, as he called them, the pure intuitions of space and time must be a priori. That is, they must be there prior to experience, not just in the sense of temporally prior or prior in time, in fact not in that sense at all, but logically prior. There must be some temporal spatial framework for there to be experience. All experience is in time and space, and yet time and space are not given by experience. So in this Kantian sense, then, we can say that there are a priori processes or conditions, a priori frameworks, that don't constitute innate ideas as such, or at least innate knowledge, but they do constitute the necessary framework within which there can be experience, within which there can be knowledge of any kind. Now, if we look at a modern psychological system that honors these Kantian notions and honors at least the Kantian sense of the a priori, as I've just described it, surely a leading candidate would be Gestalt psychology. Gestalt psychology is the creation of three German scientists earlier in the 20th century, Wertheimer, Kafka, and most famous of all, Wolfgang Köhler. They were quite opposed to what they took to be the elementaristic psychology of the time, and I should say what I mean by that. The elementaristic psychologists early in the 20th century, very much indebted to empiricistic philosophy, were inclined to regard all ideas, all experiences, all perceptions as made up of more elementary, basic sensory features, so that the complex outcome was just the association of these elemental units, these elemental particles of experience, and that the right way to understand experience then would be to break it down into its elements. The right way to understand the mind would be to break down ideas and thoughts into ever more elementary components. The Gestalt psychologists, taking the name, by the way, from the German word for pattern or form, which is ein Gestalt, the plural being gestalten, the Gestalt psychologists were persuaded that experiences tend to be of a whole, that thoughts tend to be of a whole. There is a framework, an intelligibility, a pattern to what we see and what we come to know. And they offered any number of demonstrations to establish that what we actually see is not some congeries of elements, but the scene in its wholeness and its fullness. One of their famous demonstrations is called the phi phenomenon, and advertising makes use of this all the time. Suppose you take two lights separated in space by, say, a foot or 2 feet, and you rig things such that one light comes on and off, and after an interval, the second light comes on and off. Now, you can find an interval between those two lights coming on and off where the experience is not the experience of a light coming on and a light going off, and then another light coming on and that light going off, but rather one light oscillating back and forth in space as if a single light were operating in pendulum fashion. The movement here is what is called apparent movement, or the phi phenomenon. And this comes about not as a result of something in the external world, but as a result of a transaction between characteristics of the percipient, characteristics of perceptual systems, and characteristics of the external physical stimulus. You would not be able to predict the phi phenomenon knowing only the physics of light. You would have to know, in addition to the physics of light, something important about the physiology of visual perceptual systems, and something about the innate organizing tendencies of perceptual systems, all of this now not recoverable from events in the external world, but requiring us to move, as it were, inside the organism. Now, the Gestalt psychologists also paid great attention to attention itself, expectation, expectancies, the recognition being that what we perceive in the world very often is what we expect to see there. That is, we are not passive receptacles on which experience plays on which the external world plays its various tunes, but we are active participants in our own experiences. One way of illustrating this is through reversible figures. There's a classic reversible figure. It looks very much like an urn, or it might look like two women facing each other and talking to each other, a pair of identical twins, shadowy figures. Now, you might present a stimulus like this to someone and just say, what flowers would you put in this urn? Now, if you ask that question, almost all percipients will see the reversible figure as an urn. But if instead you hand them a figure like this and say to the question is this: what do you think these two twins looking at each other are saying to each other? Then very, very few percipients will see an urn at all and will start reporting or give you narratives or tales about what two identical twins might be saying to each other. The physical stimulus in these two cases is identical. It's the same reversible figure. What one actually sees depends on what one expects to see. Not only does it depend on what one expects to see, but if there are ambiguities in a scene, the perceptual systems seem to be constructed in such a way and operating in such a way as to impose more order, more clarity, more coherence on an ambiguous scene than one would be able to extract from the mere physics of the scene. Well, the Gestaltists lay down a number of principles of perception to emphasize the tendency of perceptual systems, the tendency of percipients to impose order, to gain clarity, to create coherence, where the scene itself, the actual physics of the situation, would not by itself yield that. One Gestalt principle is the principle of grouping. You can imagine 6 lines being drawn, let's say 2 inches apart. So there's a line, 2 inches away from it, another line, 2 inches away from it, another line, you've got 6 lines. But suppose instead of that, we took a pair of lines separated by an inch, and then 2 or 3 inches away, 2 more lines separated by an inch, 2 2 or 3 more inches away, 2 more lines separated by an inch. Now, the perceptual outcome of this will be 3 pairs of lines, not 6 lines. Or there might be 3 and 3, or 6 in a row. Now, if you describe the physics of the situation, you would just say that there are 6 marks in a space of so much area. But from the percipient's point of view, there may be pairs of lines, there may be groups of 3. Where the external world allows for some degree of grouping, it is the strongest tendency of perceptual systems, thus, to group. Grouping turns out to be a way of ordering, of imposing coherence on the external world, and thus rendering our perceptions more successful in guiding our behavior, shaping our knowledge, improving our memory, and conditioning us, in a manner of speaking, to expect the world to behave in certain ways. The Gestaltists understood all of this to be the outcome of long evolutionary processes, fashioning and refining perceptual systems to render them ever more adaptive. Another Gestalt principle in the German now is the principle of Prägnanz, which is a principle of simplicity. That is, if 2 perceptual possibilities present themselves, perceptual systems tend to find the best version, the cleanest version, the simplest version, the most coherent version. A principle of closure. If I were briefly to present in a tachistoscope an open circle, and ask you not just to say what it is, but to report what you see, generally one overlooks the break in an incomplete circle and actually sees it as a circle. The system tends to close up where a regular form would be closed. And to impose an organization, I say that the pure physics of the situation might itself resist. Now, these tendencies appear very, very early in life. The psychologist Dr. Fantz, studying infants just 2 and 3 and 4 and 5 days old, 2 and 3 weeks old, presenting these infants with various figures. These are just circles in which you present something that seems to have eyes, a nose, and a mouth, or you just present irregular lines or stripes and whatever. And you measure the amount of time the infants spend looking at these things. It turns out that the infants spend very, very little time looking at circles within which are essentially random forms, and spend a considerable amount of time, a statistically significantly great amount of time, looking at anything that approximates a face. This takes place so early in life that there's a good reason for accepting, at least as a general proposition, that the visual perceptual system of the neonate, and probably during late fetal development itself, is tuned, as it were, to perceive, to pick up, to be particularly attentive to the kinds of environmental stimuli that will bear directly on survival and adaptation, and successful adaptation. Now, Köhler is a figure of great interest. He deserves a full-length biography, and I'm sure one day he will have one. There are lengthy and informing biographical sketches of Köhler written by some of his students and associates. He probably is the premier figure in the history of Gestalt psychology. He was in Germany as the Nazis took over. He labored valiantly to have Jewish families of his acquaintance get out with their possessions. He protested against the policies of the government, I think very much to his own endangerment. And finally, persuaded by his own friends, he did leave Germany. He went to Tenerife, and there he undertook studies of the great apes. He had a particular favorite named Sultan. And I think we probably can illustrate the very spirit of Gestalt psychology by reviewing ever so briefly Köhler's studies of Sultan. Now, recall the B.F. Skinner approach to studying behavior. The idea is to find an environment in which very little behavior can take place. The animal's conduct is to be focused on a small lever jutting out from inside the wall of the cage. When the lever is depressed, a magazine tray is activated, a pellet of food drops down, and you can now start recording response rates and the like as a function of reinforcement. The whole point of this, getting away from Thorndike with cats running all over the laboratory, the whole point of this is to limit the behavioral options, in such a way that you can get a very accurate and precise count on what the rat is doing. It's quite clear in this setting that rats are being called upon to do things rats are rarely called upon to do. It would be very, very rare down at the wharf that rats running along the rope from the ship to the dock would be pausing to press bars, etc., etc. Now, what does Curler do? Well, Curler has Sultan in a cage, and I remind you again of Blake, a bird in a cage puts all heaven in a rage, but that's another matter. Here's Sultan in a cage, and Sultan is rather hungry, we have reason to believe. And there are bananas hanging down from the center of the cage, from the center of this large cage, and they're much too high for Sultan to be able to jump up and grab them. But Curler has also put an orange crate over in the corner of the cage. And so if you take a look, and this actually was put on film by Curler, if you take a look at what Sultan is doing, Sultan is sort of looking up at these bananas, and looking up, and then looking down, and there's a discernible frown on Sultan's face, and Sultan sort of rocks a bit, and looks around, and does what is quite definitely a double take, as Sultan spots this orange crate in the corner. Whereupon Sultan goes over, brings the crate back to the center of the cage, steps up on it, and grabs the bananas. Applause for Sultan. Quite well done indeed. Now here's another experiment. Sultan's back in that cage, still hungry, and now the bananas are outside the cage, and Curler flips a stick into the cage. Sultan picks up the stick, and without more, goes over, puts the stick through the bars of the cage, and pulls the bananas in. Well, my goodness, that's not a doctoral level achievement. But now what Curler does is he moves the bananas twice as far away, and he throws a second stick into the cage. Now, Sultan is holding both sticks, and Sultan is quite visibly frustrated by this. Abortively, he puts one stick back through the cage and seems to recognize this is a non-starter. The bananas are simply too far away. And he sort of leans back a bit on his haunches. And apes have a way of signaling their displeasure, and Sultan is not pleased. And then he looks at the two sticks, and he sort of looks out a bit, and he looks at the two sticks again. And then at a key point, he joins the two sticks. He now has a single stick twice as long, reaches through the bars, gets the bananas, and pulls them in. What you have here, says Curler, is the sudden solution to a problem without any overt trial and error. Now, imagine yourselves B.F. Skinner or a Skinnerian behaviorist trying to put together a description of what it is that's going on that culminates in this successful performance. The environment is static. You do have two separate sticks. You've got an animal in a cage, and you've got a stimulus external to the animal by a distance greater than the length of either stick. The animal is not banging the sticks around, is not throwing them up in the air. The animal is sitting there holding them and looking first at one and then at the other, joins the two, and solves the problem. Curler was satisfied that he knew what was going on. And the reason Curler was satisfied that he knew what was going on is because this kind of performance is also turned in by human beings in comparable situations, who then can tell you why they're doing what they're doing and how this dawned on them. What human beings say in such circumstances is, well, I don't really know what I was doing, except I was trying to figure out how to get this problem solved. And then, and here's the key phrase, in English anyway, what you'll often hear is, and then, quote, it dawned on me, close quote. That is, in the very account that human beings turn in situations like this notion of dawning, that something gelled, something worked. I might have awakened in the middle of the night and had this aha experience. We all get the picture of Archimedes running down the streets of Athens nude, shouting Eureka, when earlier, sitting in his bath, he figured out how to determine the concentration of gold, silver, and base metals in a king's crown. Now, Curler referred to this kind of problem solving as insight, insightful learning. And by insightful learning, he means, and says, the form of learning that's based on a kind of vicarious trial and error. The animal is not overtly, in any muscular, visible sense, trying and failing. Rather, there must be some kind of problem-solving activity that the animal is engaged in vicariously. I'm tempted to say, and here I will succumb to the temptation, that the animal is doing it mentally. Now, the only reason that any psychologist worth his or her salt should be hesitant about talking about animals or anybody else doing anything mentally is because we had this half-century of a highly disciplined behavioristic psychology that wanted to get us out of the habit of talking about private internal mental events. And there could never have been a cognitive revolution until we overcame that scruple. We still use terms like that, I think, with a trace of embarrassment. Psychologists know when to be a little red-faced about terms like mental, thought, conceiving, and the like. Even a little bit embarrassed about a term like insight. Nonetheless, you do try to come up with an explanation that makes some sense. And since you cannot explain Sultan's behavior by way of operant conditioning, and since Sultan's behavior quite closely approximates the behavior of human beings, children and adults, in problem situations in which you have to, quote, think about it, close quote, and after thinking about it, it suddenly, quote, dawns on you, close quote, that this is the way to do it. Well, this just fits out exactly what Curler had in mind when he referred to insightful behavior. Now, is this, again, the defeat of behaviorism? And the answer to that question now and always is no. What happens when a particular school of psychology, or school of thought in general, expresses itself with sufficient clarity and sufficient detail to admit of systematic criticism, is that it begins to get transformed. What's best in it is retained, and what doesn't seem to work at all is jettisoned. Psychology still, in many respects, is a behavioral science. Psychology, even within this cognitive revolution, however, is a science or a striving science, that attempts to understand certain behavior by taking recourse to internal, yes, mental events, mental processes of an essentially cognitive nature. Now, what are we to say about the standing of innate ideas in all of this? Is this the triumph of nativism over empiricism? Well, I think what we have to say, at least about complex problem-solving situations, I think what we have to say about Fance's infant spending more time looking at something that approximates a face than looking at random figures, is that the nervous system surely is pre-wired. That is to say, evolutionary forces have fashioned the animal kingdom in such a way that the developing nervous system is developing in such a way as to anticipate the kinds of environments that species most likely will confront. There has to be some degree of pre-planning, as it were, for the organism to survive once born. This is particularly the case for organisms that are born in a fairly mature and self-dependent state to begin with. Now, of course, human beings are born and for a period of months and years must depend on elders for their sustenance and protection. But I say even there has to be a considerable degree of pre-wiring, so to speak, some sort of systematic layout that gets that infant in shape to receive instruction, to benefit from experience, to be able to have coherent, intelligible experiences to begin with. One source of confusion when one speaks this way is a confusion between a system being pre-wired and a system being hardwired. And that confusion has led to no end of even larger and more pernicious confusions. To say that the nervous system is pre-wired, to say that our perceptual apparatus, that our learning processes are preformed in significant ways, in a manner in keeping with Gestalt principles, for example, or more developed cognitive principles, is not to invoke what in the last century John Stuart Mill referred to as an Asiatic fatalism. It doesn't mean that this is now in place, formed, hardwired, and for the rest of your life, experience isn't going to make a bit of difference. Quite the contrary. All that pre-wiring says is that the system is predisposed towards certain perceptual and behavioral tendencies. Where the environment does not afford these tendencies an opportunity for expression, practice, rehearsal, and refinement, the tendencies themselves tend to become ever weaker, and indeed, as is now known, the very anatomy of that pre-wired system begins to atrophy, and pathological changes will take place in the nervous system where there is an absolute barrenness of experience, where there is no opportunity for these pre-wired systems and processes to derive the benefits of experience. So pre-wiring is not hardwiring, and pre-wiring is not a species of fatalism. Well, do we have more concrete examples of a system being pre-wired? There are single cells that have been identified in the auditory cortex of the neonatal rhesus monkey, the rhesus monkey just born. Cells that respond maximally if you present a tape recording of the distress cries of that species. That is, cells that are relatively unresponsive to otherwise ordinary sounds, but display a peak response and a sustained discharge when in fact the distress cries of the rhesus monkey species are played. There are cells found in the cortex of neonatal organisms that respond maximally to stimuli that have a certain shape. For example, the shape of a hand, a forepaw, a primate hand. Now, how is one to understand this? One understands this within a larger evolutionary context. The nervous system is not evolving haphazardly. It is evolving as a result of genetic instructions, as a result of the internal environment in which the fetus develops. It is evolving in a manner that is compatible with the sorts of environments that successful members of that species have been dealing with for many, many, many generations. Thus, it should not come as a surprise that latter-day representatives of that species will enter the world ideally suited, or very nearly ideally suited, to deal with the physical facts of that world. Now, Gestalt psychology is one of the developed psychologies attempting to account for how it is we organize our experiences, how it is from the very, very earliest time and then throughout life, we tend to impose on the external world a degree of order and coherence that will render our dealings with the world ever more effective, ever more facile, ever more efficient, so that every experience is not a brand new experience, so that each experience can be assimilated to or absorbed by ever enlarged frameworks which we can call knowledge frameworks. That is, we discover ourselves gradually moving from the stage of items that can sense things to items that impose a perceptual order on things, to items that form an ever broader and deeper knowledge base of things, so that perception begins to merge into a kind of conception. And we can spare ourselves the labors of close empirical scrutiny of the external world because we now know what the external world is made of. We then begin to see what we already know. Very much like the reversible urn and faces looking at each other. If you, as it were, know what it is you're looking at, then you see a pair of faces. If you know what you're looking at, then you see an urn. Is this explicable in terms of basic sensory processes? No. If you want to know which of the reversible figures a percipient is going to see, you have to know which of the reversible figures the percipient expects to see. We tend to see what we know in complex situations, and that's a turning of the tables on that radical empiricism that would have us know only what in the past we've seen.